Think about electricity for a second. It is literally a force of nature, raw, volatile, and honestly, highly dangerous. Yet every single day, we invite it right into our homes to power everything from our reading lamps to our refrigerators. So in this explainer, we're going to track that raw electrical power as human engineering safely tames it, controls it, and guides it perfectly into our hands.
All right, here's our roadmap for today. 1. Journey from plant to plug. 2. Wiring your home. 3. Fuses and circuit breakers. 4. Safe switching. And finally, 5. Earthing and 3-pin plugs. Let's dive right in. Section 1. Journey from plant to plug. We actually begin our journey miles away from your house, right where this power is first born.
Just picture the sheer, staggering scale of this operation. It's an incredible journey from a massive generating station moving through a complex network of substations all the way down to the city consumer. It is a highly coordinated, non-stop relay race of power. To make this cross-country journey possible, the power actually has to shapeshift. It starts out generated at 11 kilovolts, but then, and this is actually kind of brilliant, it gets immediately stepped up using transformers to a massive 132 kilovolts for long-distance travel. Why do we do that? Well, pushing that much raw current through miles of wire creates massive friction. Higher voltage means lower current, which drastically cuts down the amount of energy we lose as heat in those transmission wires. Then, once it finally hits your city limits, it's carefully stepped back down through local substations until it hits a safe 220 volts for your household appliances.
Section 2. Wiring your home. Okay, the power has safely reached your street. Now, let's zoom in and look inside the walls of your own house.
Power enters your home through the company fuse and meter, and then it feeds into what we call a ring system. Basically, imagine a continuous loop of 3 primary wires: the live wire, the neutral wire, and the earth wire. This ring runs all the way around the rooms in a particular section of the house. That means current can actually reach an individual appliance through 2 completely separate paths. It's an incredibly robust and super efficient way to wire a modern home.
Now, when tapping into that ring system to wire your specific appliances, engineers have a crucial choice to make: series or parallel connections. Think of a series circuit as a fundamentally flawed design for a house. In series, voltage awkwardly divides itself among the appliances, and if just one thing breaks, the entire chain goes dead. But in a parallel connection, each appliance is its own master. Each one gets its full 220 volts and operates completely independently of whatever else is plugged in.
And you can clearly see why parallel is the absolute winner. In a series setup, your appliances are essentially starving each other, forced to share the voltage. If one bulb burns out, the rest go instantly dark. But in a parallel circuit, every single bulb gets its own direct, dedicated connection to the full power source. They glow brightly, totally on their own terms. Section 3. Fuses and circuit breakers. Because what happens when something actually goes wrong? How do we prevent this massive power from burning our homes to the ground? Enter our first line of defense, the humble fuse. It's just a tiny safety device made of a short, thin wire using an alloy of lead and tin. But it has one very heroic job. It intentionally sacrifices itself. It relies entirely on the heating effect of electrical current. So if an overloaded circuit sends a dangerous surge of power through your house, the fuse heats up fast, hits its low melting point, and literally breaks the circuit before it can destroy your expensive electronics. For the heavy hitters in your house, like a refrigerator or an AC unit, we use specific enclosed cartridge fuses. These guys are carefully calibrated with very specific current limits, say 5 amps or 15 amps. When the current spikes past that strict threshold, the wire inside that little glass tube immediately melts, cutting off the danger instantly.
So here's an absolutely crucial zero exceptions rule. A fuse must always be connected to the live wire, always. Think about it. If it's accidentally connected to the neutral wire instead, and a surge hits, sure, the fuse will still blow and the appliance will shut down. But that appliance is still directly connected to the high-voltage live wire. So if you go to inspect it, you become the new path to the ground, and you'd receive a fatal shock even though the device is technically off.
Well, fumbling around in the dark to replace a melted wire is a bit of a nightmare, right? That's why today we've mostly moved on to miniature circuit breakers, or MCBs. They do the exact same heroic job, but they're completely mechanical. When a heavy current hits, the MCB trips and physically drops the circuit in about 25 milliseconds. To put that into perspective, that's more than 10 times faster than you can blink. Once you fix the issue, you literally just flip the switch back up, way safer and vastly more convenient.
Section 4. Safe switching. Let's zoom in even closer to something you interact with every single day, the everyday light switch.
A switch seems super simple, but where you place it is quite literally a matter of life and death, following that exact same logic as the fuse. It's totally deceptive, right? If your switch is incorrectly wired to the neutral line, turning it off does stop the bulb from glowing because the circuit is broken, but the appliance itself, still fully connected to the live high-voltage wire. It's just sitting there waiting to shock you the second you try to change the bulb. The proper way is ensuring the switch completely severs the live wire itself.
And honestly, this live wire reality is exactly why you should literally never touch a switch with wet hands. Water from your skin can easily seep right into the switch housing. It forms a highly conductive little bridge straight over that tiny gap to the high-voltage live wire inside. The current doesn't care if the switch is on or off. It'll just use that water to reach your hand.
Finally, Section 5, Earthing and 3-pin plugs. Let's talk about the ultimate safety net, local earthing and that actual plug you hold in your hand. Picture this, the insulation on a live wire inside your electric iron phrase and the raw wire touches the metal casing. You grab the iron and bam, you get shocked. This is where earthing steps in to save the day. That metal casing is connected to an earth wire, which physically runs all the way down to a copper plate buried deep in the ground right outside your house. Since the ground is a path of zero resistance, the earth wire acts as a high-speed emergency highway. It immediately pulls that fatal current directly into the earth, blows your fuse, and saves your life. Think about the standard 3-pin plug for a second. The earth pin at the top is intentionally thicker and longer than the other two, and that is just brilliant engineering. Being longer means that the very first thing that connects when you push it into the wall is that earth safety net. The safety gates open before the live power even has a chance to engage. And being thicker? That means it's physically impossible for you to accidentally jam the earth pin into the live hole. Now, to keep all of this straight and make sure electricians worldwide wire these systems safely, we rely on very strict color coding. Back in the day, live was red, neutral was black, and earth was green. Today, we've shifted to a new international standard to avoid total chaos. Now, an electrician in London and one in Tokyo can both easily spot the danger. Brown is for live, light blue is for neutral, and green or yellow is for the earth wire. No matter who opens up the circuit, they know exactly which wire carries the beast.
So, electricity really is a beautifully tamed beast, working quietly for us every single second of the day. But it only remains tame because of these incredible, completely invisible systems: the voltage steps, the parallel rings, the strict live wire switching, and those deep ground connections. So next time you plug your phone charger into the wall, take a look at that long earth pin and ask yourself, is your home truly protected and ready to take the hit? Thanks for learning with us on this explainer today.